Hi, I'm Rob Rigler and welcome to the next video in the NxEditor tutorials. In this video I'm going to be looking into some more advanced programming concepts in relation to the NXC simulator. In the last video we looked at identifying the ports on the robot, A and C, which are the wheels, using onRev, onForward and wait to make the robot move forward, backwards and left and right at varying speeds, and off to turn off the motors. The first topic area I'm going to get into in this video is commenting. Now, as the name suggests, commenting is the act of putting notes in the code. It allows you to describe the code without interference from the compiler. To put in a single-lined comment, use the // You can see once you do the // the color of the text will turn grey. And we can type our description of the line there or the block statement. You can also create multi-line comments. To do this, use / asterisk and asterisk / to close it. And all the lines within those two symbols will be commented out. The next section I'm going to be looking at is variables. Variables are a way of storing data. They allow us to easily manipulate and read different parts of our program by making it more verbose. Let's go to our NxEditor and create a new file. Let's create our main function and then type the following: int time equals 1000, int speed equals 50, on forward out AC speed wait time on rev out AC speed and wait time again. Looking at line 3 of our code, we've got int time equals 1000. This means that we've created an integer variable. We use the keyword int to declare an integer, and time is the name we've given our variable. Similarly, the next line down we've created another integer variable called speed, and this time with the value of 50. Speed is used in our forward and reverse commands, replacing the number that normally came after the comma. Time does the same thing, but with the wait command. So we can see that time has replaced the number of milliseconds. So when our program waits, it will wait for 1000 milliseconds. And similarly with the forward and reverse commands, the speed will be set to 50% speed. If we build and save our program, and then run it, it should move forward for 1 second and then move backwards for 1 second. Variables can be in many types and can be used in many different situations, but for now we'll only be looking at integer type variables because they do the most for us. Next, I'm going to be looking into random numbers and conditionals. Random numbers and conditionals. Whilst random numbers might not always be useful when creating purposeful programs, they're great for when you're testing a program, but also for seeing how a program will function under strange and varied input. Let's get straight into it, create a new file, and create our task main. Then we're going to create two integer variables, one called random underscore time and the other called random underscore speed. Then we're going to assign these two variables some values, or a random value. So we're going to type random time is equal to random with a capital R and 2000 in the brackets. And then similarly we're going to write random speed is equal to random 100. Then on forward out AC random speed, wait for a random time, then we're gonna go in reverse at a random speed, and then again wait for the random time, and then turn our motors off. Build it, see if there are any errors. There are none. Okay, so on line 3 and 4 we've created our two integer variables, random time and random speed, and then below that we've assigned them two random values. To give it a random value we've used the keyword random, and then the number in the brackets indicates the upper limit. So random time could have any value from 0 to 2000, and similarly random speed could have any value from 0 to 100. These two values are then used in our program. So random speed controls the speed of which we go forward and reverse, and random time dictates the time we wait for. So what should happen when we simulate this is that it should move forward and backward at a random speed, and then when we start the program again it should do something entirely, well, not entirely different, but it should move forward and backwards at a different speed and for a different time. As you can see there, yep, it behaved differently every time we ran the program. So on to the next stage, which is conditionals. A condition is a requirement that needs to be met before you can move on to the next stage. And in coding, it behaves exactly the same. It follows the syntax if, then a statement in brackets, and then there are code in curly brackets. So if this statement is true, it will then do this code. If this statement is not true, then it will skip this code entirely and go on to the next line. So let's begin by creating our task main. And then create an integer variable called myVar. Give myVar a random value up to 100. Then type if, open brackets, myVar is greater than 50, close brackets, then open your curly braces, on, forward, out a, comma 50, wait for 1 second, and then off, out a. Then outside of those curly braces, type another if statement, this time if my var is less than 50, open curly braces, move forward for out C, comma 50, again waiting for 1 second, and then turning that wheel off. Let's build, see if there are any errors. Taking var out there and resume. Let's go through this code. Firstly, we've got our variable myvar, which holds a random number between 0 and 100. Then we come to our conditional, and the condition is if myvar is greater than 50. So if the random number assigned to myvar is greater than 50, we are going to move forward for the right wheel for 1 second, and then turn that wheel off. And then for the next conditional, if that random number assigned to myvar is less than 50, we need to move the left wheel forward for 1 second and then turn it off. So for this first conditional, it checks if it's greater than 50. If it's not greater than 50, then all of this code in here will be ignored and it will move on to the next if statement. So let's run our program and see what happens. See that the left wheel moved forward for 1 second. If we keep on pressing start program, we can see that it doesn't do the same operation each time. Currently our code consists of two conditionals. One that checks if myvar is above 50 and another that checks if myvar is less than 50. This can be written in a much more efficient way by using an if-else statement. If-else is an extended version of an if statement, but if implied that the statement is not true, then the compiler will automatically jump to the code marked by else. So let's modify our program to use this else. If we remove if and type else here, and then remove the statement, then build our program and run it, we can see that our program still carries out the same function, but is much more efficient. If the value of myvar is less than 50, it automatically jumps to this else keyword.